John Everett with Zurn Industries. Today I'd like to talk to you about the new Zurn Wilkins 300 AST series stainless steel backflow prevention assemblies. These backflow preventers are an extension to our existing 300A series line, and I'd like to talk to you about some of the technological advancements we've made within this valve itself. Before we start though, let me tell you what we are going to have available for you. We'll have the Model 350 AST, that's going to be a double check valve assembly. We'll have the 375 AST, that will be your reduced pressure principle assembly. We're also going to offer these as detector assemblies, and one other additional valve that we'll offer, I think that you'll find very useful for you, is the AST-R series valves. They're replacement valves. They're made to replace a valve that's an existing lay length out in the field without changing all the risers and the piping associated with that valve. We do that by adding a custom link spool to the valve itself. So basically you give us the dimensions, we make the valve to those dimensions, and it's a drop-in replacement for you. But let's talk about some of the technological features and advancements that we've made within the valve itself. And I'd really like to start with the compound check. Now many of you are familiar with the compound check. We even have a video out about it, talking about how it reduces the head loss characteristic of the valve. It's a tried and true design that we've had for a number of years, but we felt that we could make it a little bit better. So focusing on this particular check valve, again, we call it the compound check. What we've done is we've slightly changed the geometry on the ramps that the rollers and moment arms made up with. By doing that, it effectively lowered the peak on the flow curve when we initially have the valve opening. So it really makes for a much flatter curve. I think that the peak is not really a problem for anybody per se, but the flatter that you can make a backflow curve, the better off that you are. We're trying to reduce the head loss in the backflow preventer, and by making those changes in the geometry of those ramps and rollers, we've accomplished that. Now, while I'm talking about the check itself too, I want to point out that when we look inside of the body, we have what we call a check reinforcement ring, and that's the actual ring that the check valve sets within. We've tightened the tolerances considerably in the check reinforcement ring so that we no longer have any check movement. Now, that's important, especially for the backflow tester. What it does is it serves to increase the first pass yield of his testing. For example, if you're back pressuring the second check in a RP or a double check and you have check movement, that acts very much like having discompression, and that causes the tester to have to retest that check a second time. So by Zurn Wilkins tightening up those tolerances, again, that's going to give us better first pass yield with respect to the tester testing that backflow preventer. Now while I'm on the topic of that reinforcement ring, we've used that reinforcement ring to our advantage to make a very stiff body. What we do when we install the reinforcement ring within the body, the two body halves, I have a tail piece here and then the main body and then another tail piece on the inlet. All three of those components, the tail piece, the body, and the reinforcement ring, are butt welded together. And what that does is it serves to dramatically increase the torsional and flexural stability of the valve. So if the valve's installed in the field and ultimately we end up with a little pipe misalignment, the valve's not going to twist, render itself inoperable, it's not going to cause damage to it. So again, the check reinforcement ring really stiffens up the body. One other feature that we added to the 300 AST series was how we would sense the inlet pressure in an RP. Now I pointed out to you we do have a double check valve here, but if this was constructed as an RP, we would have our relief valve on the bottom. And what we usually do is we come from the bottom of the valve with a high pressure sensing line over to the relief valve itself. Well, with that pressure sensing line being attached to the bottom of the body, it's susceptible to picking up debris and having that go into your relief valve. What we've done is we've gone and moved that sensing port location over to the side of the valve. That way we get it out of that debris path or any debris that could be laying on the bottom of the valve. And that gives us somewhat of a flow clean feature for that fluid going into the relief valve. Again, the high pressure sensing. In addition to not having that down on the bottom of the valve, when we move the sensing port, we put it in a location next to the reinforcement ring, the check reinforcement ring that I spoke of internally. We caught a high pressure area, therefore that eliminated the need of having that pitot tube that you're familiar with the other ductile iron valves. So all in all, we feel that that really, it made a better valve. It made something that we don't have to worry about in the field of checking and cleaning. We know that it's out of the flow path. We don't have to worry about the pitot tube. So those are just a couple of the features and benefits that we've incorporated into the 300 AST series valves. We're very pleased with it, and we think you'll be very pleased with it too, and we certainly hope that you'll give it a try. I'd like to thank you for watching our video today. If you enjoyed this video, please subscribe to our One Zurn YouTube channel. For more product information or to speak to a customer care representative, please visit our website at zurn.com.